Now this question says that Nigo traveled from his home to his friend's house 40 kilometers away. He stayed at his friend's house for 30 minutes. Nigo then traveled home. Here is part of the distance time graph for Nigo's journey. And this is the distance time graph. Distance time graph is just a graph, okay, that you're plotting with distance and time. Distance on the y-axis and time on the x-axis. Okay, it's just like your normal graph. It's just like a normal graph, but this time around you plot distance this way and time this way. Okay, now the first question says, what time did Nigo leave home? Actually, from a distance time graph, you're actually given a distance time graph and you're asked to find out some things from it. It's not as if it's not like the normal maybe quadratic and linear graphs that are given. It's just for you to determine some values from it. Okay, the first one says, what time did Nigo leave home? From here we're told that he traveled from his home to his friend's house. So the time that he left home, we'll be able to find it from the beginning of the graph here. So our own calculation, this is 10.00 hours, this is 10.20 hours, and from here to here you have about 10 boxes. So that means that each one is 2 centimeters or 2 units rather. Okay, now this one being here, we'll have to count the number of boxes that are available from here, from the beginning to this place. So you have 1 2 3 4 5. So 5 times that 2 units is 10. So this place is going to be 10:10. So the time he left home is 10:10, probably a.m. Okay, so how far was Nigo from home at 10:20? We're asked how far Nigo was from home at 10:20. Now we're going to trace 10:20 on the x-axis because this is the axis that represents the time. So when you trace it, you trace and find out the point that it touched this graph. So from 10:20 it's going to be here, so we'll have to trace it to the y-axis. So it will be this one now. Now for each about 2 centimeters, I think it represents 10 units. So we'll have to find out the calibration used between this and this. This is 0 to 10, and we'll have about 1 2 3 4 5 6 7 8 9 10. So each box represents 1 centimeters. So from here we'll start counting the boxes from 10, so we'll be able to find out the particular calibration this one will be. So we have 11 12 13 14. So this one will be 14. So 14 kilometers. So therefore Nigo was 14 kilometers away from home at 10:20. Now in the next question we're asked to complete the graph. Now completing the graph means that, when he left his house and the graph started going upwards. Okay, that means that as he was going away from his house, the distance was increasing and the time was increasing too till he got to this point. And we're told that he stayed in his friend's house for 30 minutes. So this point to this point should be 30 minutes, the time that he did nothing. So we need to verify if that's actually 30 minutes. So we have 10:40 here, and then we'll have 11:10. So this is 10 20 30. So this is complete. This part is complete. Now we're also told that he then traveled back to his home. Okay, now traveling back to his home means that instead of having this graph now that he was going away from home, we'll have another one coming down this way with the same average speed. So to do that, now from here we make sure that what we have here will be the same thing with this side. So from here now we will see that we'll have 1 2 3 boxes. So we also count the same boxes to the right now. So from this main line you have 1, 2 and 3. So the end point is going to be here. So we just take our ruler and have 2 points, this and this. Then we'll join the 2 points. Joining it, the graph is going to be this way. So it's just like saying whatever average speed you had here will also be the same one that you have here, except if you're told otherwise. But apart from that, this should be the same as this. Then this is the time he spent at home, or in his friend's house rather. So that's it for distance time graph.